How many possible outcomes exist in the example? A math quiz has 5 multiple choice questions. Each question has 4 options, A, B, C, or D. Ooh, let's do a little fundamental counting principle. And of course, you can't spell fundamental counting principle without fun and prince and count and ting. But what you do when you have several things going on is you use the fundamental counting principle, which means you multiply. So problem number 1, question number 1, how many options do I have? 4. Question number 2, how many options do I have? 4. Question number 3, 4. Question number 4, 4. Question number 5, let me see, 4. And you multiply everything in between. And 4 times 4 times 4 times 4 is 1,024. So that's how many options there are. So one option is A, and A, B, and A. And if you were to do that, you would have to do that 1,024 times. So that's the fundamental counting principle. See, I told you it was fun. List all the possible permutations. You got yourself a smiley face, a sun, and a heart. Well, permutations is how many ways can I reorganize this thing? Well, thing number 1 is I got smiley face, I've got the sun, I've got the heart. So that's way number 1. If I were to start out with the smiley face again, my other option is smiley face, heart, sun. So let's start out with the sun. If I start out with the sun, I could do sun, heart, smiley face, or I could do sun, smiley face, heart. As you can see, I'm not much of an artist, especially when I start to get lazy. What didn't I start out with? Heart. You should always lead with that, am I right? Then smiley face, and then the sun. And then last but not least, heart, sun, smiley face. So 6 of them. And those are all my possible permutations, which means how many ways can I rearrange this to create something unique? Well, there they are. Evaluate 8 permutations taken 5 at a time. There's 2 ways to look at this, okay? This is the lazy way to look at it. 8 times 7, 2 times 6, 3 times 5, 4 times 4, 5. So what you do is you write out what 8 factorial is until you do 5 numbers, but I don't want to use that. That's just a lazy way. That's a lazy way. Don't want to do it. Don't want to do it that way. The permutation formula is if you're given, and let me actually write it all out. If you have NPR, National Public Radio, NPR is n factorial over n minus r in parentheses factorial. So this is my n, this is my r. So I have 8 factorial over 8 minus 5 factorial. Remember, factorial means you start out with that number and you multiply one integer less until you hit 1. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times an unnecessary 1. Now this is the same as 3 factorial. So 3 times 2 times 1. Now, I know that when I'm multiplying straight across the numerator and straight across the denominator, that anything that's the same up here, that's also the same down there, I can just cross out. So this happens, which means I end up with 8 times 7 times 6 times 5 times 4, just like I did up here 2 minutes ago. Now, the reason why I'm showing this step is if the numbers are nice, then I can just multiply these guys together. Well, the numbers aren't nice, and I can't do that in my head, so I did it in the calculator ahead of time, and I got 6,720. Perms, not just for hair anymore, they're also for mutations. Like and subscribe. Find the number of unique permutations of the letters in every word, every. I don't know why I said every before every word. It should be the word, but whatever. Every. Well, there's 5 letters here, but the thing that's very important is 2 of those letters repeat. If none of the letters repeated, it would just be 5 factorial. Then I'd call it a day and everybody would be happy, but that's not what I have at all. I have 5 numbers where 2 numbers repeat. If you are asked to take a permutation, okay, and that's what we have when you're rearranging things, and it says permutation, you do NPR. Okay, the total number of objects you have, you're taking R of them at a time. And depending on how many repeats you have, you just take that many factorial, do it again if you have to, do it again if you have to, so on and so forth. Okay, so if I was asked to do like Mississippi, for example, I have a bunch of P's repeating, I have a bunch of I's repeating, I have a bunch of S's repeating, and I might do like 2 factorial. For like the P's, and I don't know, like I think 4 factorial for the S's, MISSISS. So yeah, whatever. Here, I'm being given 5 total letters, and I'm taking all 5 of them at a time. And that's going to be over the fact that 2 of my letters repeat, and that's the only things that repeat. So 5P5 is the same as 5 factorial over 2 factorial. Let me write it down here. 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Now, if you have something across the top that's same as the bottom and all you're doing is multiplying straight across, you can get rid of them. And now I don't really need a calculator. 5 times 4 is 20 and 20 times 3 is 60. So there's 60 ways that I can rewrite every to create a different thing. And again, since 2's repeat, I'm not going to be like, let's do EEVRY and then switch these E's to make EEVRY. No, in this case, these guys are the same, so we're not going to repeat ourselves. And that's why I divide everything by 2 factorial, so I can get rid of all those repeats. That's it. List all the possible combinations if I give you 3 letters T, V, and W taken 2 at a time. All right, so with a combination, the order doesn't really make it any different. So TV and VT are the same thing. So I have T and V can match up, I have T and W can match up, and I have W and V, or VW, Volkswagen, can match up. And that's it. And if you're wondering, well, what about WT? What about WV? Nope. Combinations, we don't care about the order. So I only have 3 of these guys. That's it. I'm done. Evaluate 18 total combinations, but only taking 5 at a time. I have NCR, and the formula for NCR is n factorial over n minus r factorial. And before you yell at me and say, this is the same as permutations. No, it's not, because this guy adds an r factorial also on the bottom. So what I have here is I have, you're my n, you're my r. I have 18 C5, which is 18 factorial over n minus r factorial. So let me see, 18 minus 5, 13 factorial times r factorial, which is 5 factorial. Now, this might be overkill, but I'm going to write this all out and then all of a sudden start using common sense. I have 18 factorial. Let's write that out like I said I would, and then I decided I wouldn't do it. 18 times 17 times 16 times 15 times 14 times, ouch, my hand hurts. So I'm just going to write 13 factorial. I could write 13, 12, 11, 10, but wait a minute. 13 factorial is already on the bottom. Oh, let's just get rid of those. And then I have 5 times 4 times 3 times 2 times 1 from that 5 factorial right there. Now, I'm going to make life a little easy. 15 is the same as 5 times 3, so we can cross those out. But unfortunately, there's not much more I can cross out. So if the numbers were a little bit more pleasant, maybe I can pull that off and get some numbers that I can multiply together in my head and be okay. That doesn't really happen here. So I ran to a calculator ahead of time and found out that this whole thing ends up being 8,568. Okay. So that's combinations. With combinations, something like VT and TV are the same exact thing. We don't worry about order. Order doesn't really matter like it does in permutations. That's why that extra R factorial is there, because order doesn't matter. If I were to give you something like TV and VT, I'm just going to say, well, those are the same thing, so let's kind of get rid of all those repeats. But that's what I have here. Those are combinations. Baby. You're going to hate this one. State of the scenario involves a permutation or a combination. A permutation means that something like ABC and CBA are two completely different things, whereas a combination tells you that CBA and ABC are the same thing. So I have to find out the number of possibilities once I figure out what is this, a permutation or a combination. So you might be thinking, well, you said I'm going to hate this. Why am I going to hate it? That's not so bad. You are setting the combination on a 5-digit lock. The answer seems kind of obvious. You want to use the numbers 62413, but you don't care what order they're in. You're automatically thinking, I don't care about order. And it says the word combination, it's going to be a combination. Wrong. It's not a combination. Because if you don't care what the order is in, then I can give you 6, 2, 4, 1, 3, and that doesn't matter. And you're like, that's fine. And then I'll be like, well, how about 6, 2, 4, 3, 1? And you'll be like, that's fine. Or how about 2, 6, 4, 3, 1? And you could be like, that's fine. And I can go all the way down the list and tell you all these different permutations, and you don't care which one, just list all the possibilities. So after all of that, and seeing that word and seeing the phrase don't care what order, you would think combinations, but it's not. Tricky, 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 tricky. Permutations. Now, I have 1, 2, 3, 4, 5 numbers, so I have 5 total permutations, and I'm going to take, are any of them different? Nope, they're all unique, so I'm going to take all 5 of them at a time. No repeats, so I don't have to worry about repeats and dividing stuff. So it's just going to literally be 5p5. And whenever you have 5p5, it's just that number factorial. So this is 5 times 4, 20, times 3, 60, times 2, 120, times 1, still 120. 120 different permutations, even though it says combinations in it. I hated it. I hated it. Tricky. But don't be fooled by the rocks that I got. Jennifer Lopez. Jennifer Lopez. She's from the Bronx. Like and subscribe. Cody is carrying 7 pages of math homework and 3 pages of English. Oh, that's the way it should be, Cody. Math is more important. A gust of wind blows the pages off of his hands, and he is only able to recover 7 random pages. What is the probability that he recovers all of the math homework? Well, we have 7 maths, and we have 3 Englishes, giving us a grand total of 10 pieces of paper. All 10 of them are laying on the ground. He picks up one of them. The probability that he picks up a math one is 10. Then he picks up another, but there's only 9 left. Also, there's only 6 math ones left. Then he picks up another one when there's only 8 total papers left, and there's 5 total math ones left. Oh, pretend I didn't put that dot there. That means nothing. I'm trying to lead to something. All right, 7 total pieces of paper left. 4 of them are math. 6 total pieces of paper left. 3 of them are math. 5 total pieces of paper left. 2 of them are math. 4 total pieces of paper left. The last one is math. Whenever you're doing probabilities and you're doing different probabilities, different events at the same time, you multiply. Multiply, multiply, multiply. That's the fundamental counting principle. And I'm not going to pretend like I did this all on my own. I didn't. I used the internet and I got 1 over 120. So you're thinking, oh, 7 out of 10 pieces of paper, I'm probably going to pick up all math. No, you're probably not going to pick up all math. Probably not at all. And the probability of me getting only 7 pages of math, even though there's more maths than English, is not high at all. It's 1 out of 20. That's less than 1%. That's how you do it. A class has 6 girls and 5 boys. If the teacher randomly picks 6 students, what is the probability that she or he will pick exactly 3 boys? 3 boys. All right, so we've got 6 girls, 6 G, and 5 boys, giving us a total of 11 children. Okay, so me closing my eyes and picking, what am I doing? A boy is right now 5 out of 11. Me picking a boy again, well, there's 10 students left, is going to be 4 out of 10. And me picking a boy again, if there's 9 students left, is going to be 3. Now I have to pick only girls. So there's 8 students left, 6 girls, 6 out of 8. 7 students left, 5 of them are girls. 6 students left, 4 of them are girls. When I multiply all of this together, I end up with 5 out of 231. So not very likely. Not very likely at all. But this is me closing my eyes with a room that's nearly half boys, half girls, and saying, I only want the guys. Probably not going to happen. You're probably going to pick a girl. But it's possible. It's not likely.